So yeah,
Is it
basically,
working?
before I start
gotta-
with literally anything,
Yeah.
I want to say that I have no idea what I'm doing. I got into CV2 basically just jumping into Cold River. I had no clue about anything. I had a bit of prior CV1 knowledge, but essentially that's it. And what I'm basically trying to say, if I can do it, you can. Like, all of you can do it. No problem. Because I'm not the smartest person. Like, I'm not the sharpest tool in the shed, as they say. So, CV2 is kind of unintuitive to begin with when you don't really have any idea about circuits. But once you understand the fundamentals, you can just kind of start messing with things and looking what it does. And then it all becomes kind of self-explanatory. So I basically just learned it by trial and error, and I'm gonna be teaching like the complete like bare bone basics. I'm not gonna go too complicated, I hope. I have a long script, so I hope I'm not gonna bore you guys. If I bore you guys, yell at me. So that's essentially my opening for that. If there's something
Nice
I can ask, what is your circuit knowledge in CV1? If you have any knowledge, like, can you raise a hand? One.
I'm
Any
extremely-
knowledge?
Any
Extremely
CV1
basic
knowledge?
knowledge. Extremely basic.
Some.
Okay.
Very
Okay.
little.
About CV2, like anything? Have you touched anything? Like, raise a hand if you have.
Jeff, Jeff is
I,
obviously gonna
I've
raise his hand.
touched it, but like YouTube tutorials.
Very
It's like
little.
Okay.
so and so.
Okay. That's good to know. I know we have some like seasoned veterans in here, and I applaud them to like easily correct me if I'm saying something stupid. I'm Jeff. So don't mind me. Basically, I'm gonna get all the dry things down the line quickly as I can, so you guys don't fall asleep like the last person I tried teaching. And once we're done with that, I promise it's gonna get better. There's gonna be some like, practice things you guys can do, like practical stuff. I have some stuff prepared. It's gonna be okay. So.
Yay.
There we go. So before anything, not a lot of people know this, but logic gates are actually not that hard to get into. Like everyone heard, like how does a computer work? Oh, ones and zeros. Everyone's heard that in their life, and that's practically kind of what this is. You just have ones and zeros, which is what we call binary and yada yada. Zero is off, one is on. Light bulb on is a 1, light bulb off is a 0. That's kind of what this is, but true and false. So false is 0, and 1 is true. All you need to know about this are these logic gates. So basically, not gate, just inverts the input. You just take the input, anything you input into it, it inverts, no matter what. It's rather simple. It's like just like shown here. And then you have the OR gate, which if any of the input is true, it will output a true. It doesn't matter which one, doesn't matter if it's all of them. As long as one of them is true, it will output true. As for the AND gate, every output has to be true for it to output true. That's all.
Okay,
Weird?
makes sense.
Confused?
Cool.
Yes? No? Anyone confused so far?
Any questions?
What does it? What does AND do? Is AND the one that you just said? The last thing.
Yes.
Basically, if
Okay.
all the inputs are true on it, then it will output true. There's no other way. Only if all of the inputs are true. That's it.
Okay.
And as for the
Okay.
OR, it's like any output can be true. Like these are only with 2 inputs each, but in CV2 you can go ahead and configure it, and you can add as many inputs as you want. I think there's probably a limit, but you can input a bunch of them. This is important
Okay.
later on, but for now you just need to know that these, like this true and false, is what's called a boolean, or a bool, as in short. It's one of the variables that will be important later on. Like a lot of chips use this, so that's very important to know.
So bool means
Uh,
1, 0, basically, true or false. Okay, that's just trying to remember.
Exactly.
Yeah.
Exactly.
Awesome.
Questions so far? Confusing? Yes, no? No? I'll take that as a no. Okay. If any of you is ever confused, just like yell at me. You need to come closer though because the voice roll off is low. Cool. So, there we go. I'm gonna get into some simple rules of CV2 that you need to know, which is basically that the left side is the input side, and side is the output side. It's it's just the basic that you need to know. So when you're messing with any and all chips and you're assigning them and placing them, that you know that you can sometimes input multiple things on an input, or sometimes multiple things on an output, but that isn't true for everything. So you just kind of have to mess with it and use the wire tool and see what you can and can't do. And that's kind of how you just approach it. With most of the chips, it's rather self-explanatory because they have really simple names. Like, let's say, divide. Like, it divides things. That's all it does. Pretty obvious. So you just kind of have to look for the things you want to do in the search bar, and then you just roll with it, what it says. Uh, Another rule that's really important is that you don't really have the problem of ink the way you had it in CV1, because the actual logic chips like these, they don't cost ink, but they do add on to a chip limit that exists. As of now, it's 3,000. It used to be 1,000. Before that, there was none. Uh, that kind of was introduced because it would get too laggy if you had a lot of chips in the room. Now we have a sort of chip limit, I guess, but things that still cost ink are essentially like the gizmos, like the piston, the rotator, sound gadgets and stuff like that. That still does cost ink. So if you're spawning like trigger volumes or buttons, they will still cost ink. But if you're using chips like these, the only thing you're limited to is essentially a calculation limit. So let's say you're doing a lot of calculations, like a lot of things at once. You will have like CPU heat and network heat, but I'll get into that later. So there we have it. There we go. Yeah, it highly depends what you want to do with CV2 because we don't have everything yet in CV2. Like we're still missing samplers and we're still missing animations. So this is only for, I think CV2 makes for great gameplay elements at this point, but it doesn't make for a complete map, in my opinion, yet. So if you want to approach it, you still need to know how to interface between CV1 and CV2. I will do that at the end if we still have time, but for now, it's mostly important to just know that the most things you can technically still do in CV1, but there are possibilities to interface between CV1 and CV2. So that means basically if you want to play a sound that isn't, one of the basic spectrum sounds, you can technically do it. Makes a bunch of logic, but that's for later. To do literally anything, you need executions. It's basically a one-time pulse. So imagine how in CV1 you would press a button, it would output a 1 or your player ID or something. That's kind of what an execution is, but it's not really a number. It's just a variable. It just kind of happens. So imagine there's like a ball on the ground and I push it. That's the execution as of so. Like it happens locally first off, but there are ways to make it happen not locally, so other players as well. But initially, it press the CV2 button, it will only happen for you locally on your machine. That is important because that does save a bit of performance for other devices. So not all the calculations have to be done on other machines, other devices. Obviously, we have a wide variety of platforms, so it's incredibly important to try and keep all of the complicated stuff to happen for you only, as it makes it a lot better for others and it's less laggy, and generally the limitations are a bit less if you do things on other platforms. So yeah, setting off executions. You have many ways of doing it. You have events, which we'll get into later. We have buttons, we have trigger volumes. You can even set off an execution by sitting on a seat. There's a way to get an execution from that, but it's kind of inefficient, I guess. If you just want to press a button instead, that makes a lot more sense. But essentially, if you were to spawn a button, you get the chance of like wiring execution to something. There we go. So executions are most importantly for starting any kind of gadget or circuit or chip or whatever you're doing. So let's say you have a piston in CV2 that you want to start moving. It's not just going to start moving by itself. You need to somehow tell it to do that. That's what you need executions for. In the past, in CV1, you would press a button, it outputs a 1 or a 2 or whatever it was, player ID, and you would input that into the piston, and then the piston would start moving wherever you told it to. But in CV2, that works kind of different. You don't have a number input to it. Like you just kind of tell it to do it. So an execution isn't really a, a number or a letter or anything like that. It's just what it is. Does that make sense so far? Anyone confused with that? Anyone
Yeah, I'm good
questions?
with that. Yeah, it's good.
If anyone has a question, just fly up to me and tell me because I cannot hear.
So it's checking for a pulse of execution or a constant signal.
Well, what?
So it's checking for a pulse. So it was executed or it is executed. So a pulse or constant.
It's a pulse. It's like a one-time pulse. Like
Okay.
you can't have a constant execution. That isn't a thing. You can. There's a
Okay.
way to make a lot of executions at once, like 30 a second, but we'll get into that afterwards. That's for later.
Cool.
So the only problem you have with executions, of course, is that doing something that does cost like CPU and network. So basically, everything you're doing on your machine, there are calculations that need to be made. So you have to somehow mitigate that because you could just go into infinity and make it crazy. That's why we have an ink limit, That's why that was invented essentially because, there have to be limitations or people would just overload their devices and their game would crash. That's why we have, instead of an ink limit, like in CV1, we have the CPU and network heat. Essentially, if you fire an execution and it's happening locally, that one will happen only in the CPU range. Like if you, let's say, you fire off an execution and you change a variable, which we'll get into later, only you will see that. So that's only going to be CPU heat. But let's say you fire an execution that changes a text gadget, so you change text on a text gadget. That won't happen locally. Everyone will, unless you now can do that, so it only happens for you. But let's say everyone will be able to see it, so that will cost network heat. And network heat is a lot more scarce, so it's not as easy to get. Like it will heat up a lot faster than CPU. So you have more CPU heat constant than you have network heat. You got to be careful for that. But I'm gonna get into the how it works exactly more later. But for now, you just have to know that if you pulled out your pen, for example, actually I encourage you to do that right now, and you look into the menu, palette menu, and you go into circuits V2, you will see that there's a CPU, net, and chips bar at the top. Everyone see it?
Yeah, I see it.
Yeah. So that's basically what I was talking about. Like if you were to spawn a chip, for example, that chip limit will go up. If you, were to fire an execution locally that only happens on your machine, the CPU will go up a bit. And if you're doing something like moving a piston or, I don't know, like setting a tag on something, that will happen to go onto the network heat because it's something that everyone will be seeing, so it has to be transferred to everyone's client. So that will drive up the network heat. What you can do in CV1 back then, you were able to send a notification like that pops up on your screen, and it will show like, you can preset a message on there. In CV2, it's set up so you can only do it for the local person. So the person who fires off the execution is the person who will be getting that notification. So an execution is kind of bound to the person who sets it off. But you can set up an execution so it happens for everyone in the room, only the room authority or an object authority or everyone else. That is done with events. More on that later. But what you have to know, mostly everything is going to happen locally on your machine, not like with CV1 where you would go ahead and, you hover over the pin with your wire tool and you can see what someone else is doing. Like if you were to hover over someone else's circuit that someone is working on, that is active for someone else, you will not see anything because it's happened on their machine. It's confusing in the beginning, but once you understand, once you look at it and you understand how it works, you can kind of work around it and you can decide what needs to happen locally, what needs to happen for everyone, yada yada yada. Like you don't need to do complicated calculations on everyone's machines as long as you do it all on your machine and the others see all the results of these calculations. Let's say I move my hand fast and I detect that with CV2 and it plays a sound. All people need to know is that it plays a sound. Like you don't have to do all these calculations on everyone's machines as long as everyone hears the sound, right?
Yeah.
Very, very peculiar, that one. There we go. So, there we go. Okay, are there any questions regarding like how executions work? Anything? Anyone has something, just fly up to me or something? No?
Anything
Okay,
you
good.
don't understand.
Good. Good stuffs. I'm gonna scroll down a tiny bit so I can see what I'm doing. Alright, so this is why I made the if chips. It's probably, to me, one of the most important chips for, basic routing of your executions. So we already know that booleans exist, which, they consist of either true or false. And that's what the if chips are for. Basically, you can determine, like, if this is either true or false, and then the execution that will come in here will come out either on top or on bottom. It will say it on the chip, like, if it says, if, and then the then chip will be up this, like, if it's true, then it will fire up here, and if it's false, it will fire down here. So this is basically like, let's say you're waiting for a value to happen, like for a variable to happen. So let's say, I'm moving my arm fast, and I have a circuit that is constantly firing executions, checking whether or not I'm moving my hand fast. Once I finally do it, this will set to true, and then the execution will be fired from here, and you could play a sound, for example. Basically. If chips are kind of looked down upon, from what I know from a few circuiteers, because they're saying like it's not the right way of doing it, and in programming you wouldn't consist your entire program of ifs. But in CV2, it doesn't really matter. In my opinion, there are people that just completely math out their circuits, and there's other people who go more the logic approach. And I'm personally one of the more logic approach people because I'm not good at maths, and I don't know if we have any math geniuses on board, but if we do, I don't believe it's a lot of them, because math is just, for me, it doesn't make any sense. Like, it just doesn't. So that's kind of why I take the more logic approach. So you can use all these things anyway. Something that I've been told is that in order to do CV2, you need to know maths, like, because there's all these mathematical calculations. You don't need to do that. You really don't. For the things that you can believe and you know what you can do with the circuits that you have, as long as you know your limits and what you can physically do, you don't need math. You can just do it that way. As long as it works, just roll with it, really. That's basically all I can give you advice-wise. And that's why if chips to me are incredibly important, because you can make giant arrays of them and you can basically check for a bunch of things at once. And they will let you basically route. I guess routing isn't the right word, but it's the best one I could come up with for now. So it's basically sorting of executions, sorting. So yeah.
Looking for control flow?
Control flow is the word. Thanks, Jeff. Language barrier solved. All right. Also, a little thing I wanted to say is that with executions, you can input multiple executions on one pin on the input side, but you cannot have multiple outputs on the execution side. This, I don't know exactly why it was made like this, because you can get around this. It's probably due to some like calculations thing, like how to calculate the CPU and stuff. It's just hard locked into the programming, I guess, so you can't really do it. But there are ways to make one execution output to a lot of them. It's not a problem. It's just that you can't directly connect multiple things to the output of an execution pin. That just doesn't work. But you can have multiple inputs. So you have 10 different buttons that will be connected to this if chip. They can all be connected to this. But let's say you have 10 light bulbs, cannot all be connected to this. You can only connect one of them. That's just kind of how it is.
Okay.
But we can get around that using events. Again, events are very important, but that's for last. I'm digressing. So, everyone understand how if gates work, like how if statements work? Yes?
Hey Phil, if seeing that it's
Yes?
a control flow is like what Jeff said, it's a control flow. Does that mean these executions are constantly always working, like they're always on, so they're just constantly executing? I think that's what Redbeard was
No.
asking before. No,
Not quite.
exactly?
Not quite. Executions are like one-time pings. So let's say I spawned in a button. There. So if you press a button, it will only set off one execution once I press it, and one when I
Yeah.
release it. It's just like if you look at this, like with the wire tool, you will see that you can. Let me turn this around so you can look at it. If you press this, they will only fire one execution out on this. Like it's a one-time
I see.
one-time pulse.
So it's a trigger, like a triggered thing.
Exactly. There are ways to get a lot of executions at once. As I said, 30 hertz event receivers. That's for later. But for now, imagine you can only technically have like one-time pulses. Like you don't have a constant signal like you had in someone moved the world.
Someone moved the floor. Can anyone, whoever did that, can they press?
Alright.
Can they press
Who
back
did it?
perhaps?
Yeah, undo.
There we go. Thanks,
Oh.
guys.
There it is.
Cool,
Okay,
cool.
cool.
All right, so yeah, basically you can't have a constant execution. That's not a thing. But that's a good question. That's really important that you know that
Okay,
because
just wanted to make
you
sure,
will
yeah.
you will always have a bit of a gap in between the executions. No matter how fast you do it, there's a limit which is 30 times a second. As of now, we can't really change it a lot. You can only have 30 times a second or whatever you set up with like a looping thing using a delay chip. Like you could use, for example, and you can set up a delay of, let's say, 0.1 seconds. So grab a delay chip.
Is that quicker than
Damn,
30,
I'm lagging.
30 per second?
Oh no,
I
no,
don't know, my
that's
math
not
is
the
not very
30,
good.
30 times a second. So if I set it to 0.1 second, it would be 10 times a second. There we go. 0.1.
Oh, I see. Yeah, yeah, of course. That's my math. My math is pretty bad.
And no, it's fine. It's fine. It's fine. I'm not gonna make fun. I failed math twice. So there we
So
go.
I guess 0.01 would be the way to do it, because then you would obviously be having more. Is that even possible to do 0.01, or is it not possible?
I think you can
If
have a
it's only 30
0.01 delay. You can. I'm pretty sure you can have a 0.01 delay, but it will be
Wouldn't
a bit too. It would be a bit too drastic. You probably don't want to go over a certain limit. Like you will just run out of network heat, like immediately your
Okay.
CPU, depending on what you have connected behind it. In fact, if you were to press this button right now, and you look at your CPU, you will see that it starts going up because this starts looping by itself. Go ahead.
Look at the CPU. So the CPU, guys, is on your maker pen, circuit CV2.
Yeah. Yeah, and then go up and press this button. Only you will be able to see it. Like the person who presses the button will see it. Will see the CPU heat going up because it starts looping a bunch.
Oh, I'm seeing it as
Like,
well.
once
I'm
you
seeing
press-
0.6. I'm seeing 0.6 whenever
Oh yeah,
someone
it's
presses
going
it. It
up
comes
and
up as
down.
0.6%.
It's going up and down.
It's going up
Yeah,
to 0.6%
that's
whenever
that's
someone presses.
basically because it's doing it 10 times a second, and that's because this is happening all locally. Only the person who pressed see it. That's that really. And every time you press it, essentially it's gonna keep going up because it's gonna keep adding another loop to it. So that's kind of how that works. That's how you do like slower loops. Essentially, the fastest way to fire a lot of executions is to use an event receiver and use a 30 hertz, which is 30 times a second. That does drive up CPU heat very quickly, depending on what you're wiring it to. So I advise to only use it when there's no way around it, because it's one way to quickly just drain out the CPU heat in your room. So you want to be avoiding that if you can, but if it's needed, use it. And if you can, of course, keep it away from anything that happens on network. So you don't want to be having a 30 hertz on something like a light, because that'll just start flickering like hell, and the the network heat will just go into space, and then the room will just kind of not function. So you don't want to be doing that. So, yeah. There we go. Are there any questions regarding that? Like executions, ifs, looping stuff?
I have
Yes?
a question kind of with the if
Yes?
here.
Come close.
Just to see if I understand correctly with the if chip. So for example, if there was a trigger volume that was connected to the top one, and it's and what would the action that would go out from it would be, for example, it's daytime, and the action that would go out would change it to nighttime. If there was a trigger volume connected to the false one, and if there was a trigger volume connected to the true one, the difference would be if someone steps in the trigger volume. Okay, so with the true, if someone stepped on the trigger volume for true, it's true. So the sun would turn to night, the day would turn to night. If I entered a room and there's the trigger volume connected to the false, because no one's in this trigger volume, as soon as you enter, it would be nighttime until you step into the trigger volume for the false, and then it would basically do the opposite, right? Is that the difference
Not
between
quite.
the false and the true with the ifs, or?
Not quite. That's, I think you're confusing it with the old ways, how you did it in CV1. Like basically in CV1 you could spawn in a trigger volume and it has these 3 pins, right? Depending on if you're in the trigger volume, it will say 1 because there's 1 person in the zone, and then you can add like not or chips and all that. But this works differently because the CV2 trigger volume has different kind of outputs. Let me actually spawn one in real quickly. There we go. Gonna rotate it. So if you come here, you'll see on this side you'll see the chip. This side, this side, this side. There we go. You'll see that this doesn't really have a Boolean output for when someone is in the trigger volume. What you can do though, you will get a list of players that are currently in the trigger volume. So that way you know someone's in the trigger volume. So what you can do, there's a chip called list count. So you search it up, list count, list get count, and you just kind of cut it to that. Oh, there we go. And you will see if you hover your, like, grab your wire tool from your makeup pen, and if you hover over this pin here, the green one, the int, you will see that it will show the amount of players in the thing right now. So basically, from there on out, you can set this up yourself. Like this is kind of the same output that you had on the CV1 trigger volume.
Oh yeah.
You know,
Right.
because it's just like the green output on the CV1 trigger volume. So what you can do, you can set up either a, I think you could technically use an isValid chip, which would give you a Boolean, but the probably smarter way is to just use a greater than chip. It's pretty self-explanatory. You just connect it to that. There we go. And this will just check if it's greater than 0. So if it's more than no one, and it will output true. And if I leave out of it, it will say false because I'm no longer in it. And there's, you know, that's it. That's how you would do that, essentially.
So you don't need
That
the
makes
list
sense.
count. You could have just done greater than without the list count, and then that would still work. Phil?
No, because lists are weird. You have to get the, like, you don't have a direct Boolean output like this. Like you don't have that here
Oh, I
on
see.
the trigger volume chip.
Happy
So
hell.
you have to get the count of the list of this.
Oh, that's a good idea.
So it will tell
You
you
know,
like how
shrunk
many
and stuff.
players are in the trigger volume. Variables, variables. Funny word that I can barely say. So we already know a few variables. The Boolean, we've already talked about it. True or false. We already got this. Variable chips are just kind of your storage containers for your variables. They can be either locally, like said, or they can be synchronized. Basically, if you need to have a variable in multiple places, let's say you have 10 of the same chip with the same name, and you want the variable to be on each of these chips, so you have it more organized, or so you can quickly work with it. You want to sync the chip up. This will cause heat though, because it will sync it up with everyone in the room. If you're doing the things locally because you just need a quick storage, then you can do everything locally. Store something in a variable chip, you put the variable, like, you know, whatever you need, into this here, and then you just fire an execution onto it, and it's stored, and it will come out the other side. But if this input changes, but it doesn't get an execution, it will keep it here. So let's say I fire an execution while this is saying true, then on the other side it will say true as well. But if this changes to false again, the other side will still say true because that's what it has saved. Does that make sense?
Because that what?
It's kind of like a storage container. Yeah? No? Confusing?
Can you say that last? Can you say that last part again for me? I'm sorry, I must have missed it. The false and true.
Oh, basically these are storage
Fine.
containers. Like whatever you input on this side, it will save it once you fire an execution into this. If this
Okay,
variable
so it
changes,
saves
down the line with firing execution into this, it will keep this, whatever it has saved. Yes? Yes? No?
So you have to have one of
Uh,
those extensions attached to that for it to change anything. Gotcha.
Yes. You need to, let's say you have a button that is connected to this, and let's say you have something that checks whether or not the trigger volume has people in it, like we've done before just now. And if you want to save that whatever it is right now, you would press the button while this is connected to that. And let's say there's someone in the trigger volume, so the trigger volume setup thing that we had, it would output true into this. And then once you fire an execution, it will save that it was untrue, and it will say true on this side. But if, let's say, no one is in the trigger volume anymore, and it will put a false here, this will still say true, because there isn't an execution fired into this. Unless you press the button again,
I
then
get
we'll
it.
save the new variable.
Okay. I see.
Yeah?
Okay.
Yeah?
Yeah.
Okay. That will make more sense with numbers, I guess, because that's essentially what these are. Flotation device, whatever, flotation point, whatever. I don't know. They call them floats. You just say float, essentially.
Floating point numbers.
Thanks! Nameless told me like 2 days ago, and I was super sick, so I didn't remember. So yeah, floats. Essentially, decimal numbers, but they don't have to be round flat numbers like, they can have something behind the comma, basically. That's all it is. That's all really. And that's where integers come in, because they're essentially directly the opposite. You have numbers, but nothing behind the comma, so they have to be round numbers. Yeah? Yeah? No? Yes? I'm getting
Yeah,
nodding,
yeah.
so that's good.
If you
Good.
if you put a float into an int, does it round it for you?
No, it doesn't.
You won't even take
There's
it.
conversion chips. You
Okay.
need a chip to convert it.
Okay.
There's chips to convert anything into anything, pretty much. Like, I'm pretty sure you can convert almost every variable into something else. Like, you can almost convert everything into everything. You need to help it a tiny bit, but you can make integers floats. You can make floats to integers. Like, it can round the integer to be a float. Well, you can round the float to be an integer, because it will just basically chop everything off that's behind this dot, and it will put it to the closest next full number, and then it will become an integer. That's kind of a thing you have to know in CV2, that you cannot cross-connect variables. Like, let's say you have an add chip, so you add A and B to each other. It has to be the same data type. Like, you want to add a float to an integer, you have to convert them to be the same first before you do anything. This is with a lot of things. Some chips only allow certain data types, so you have to first get it converted to that data type. It seems a bit complicated in the beginning if you haven't touched it yet, but if you basically just look up whatever data type you're messing with, so you just go into the search bar of CV2. Actually, I encourage you to do it right now. Just open your palette and look into CV2, Circuit CV2 in the top right, and you just press search chips. And then you can just look up float. And then you will find int to float, parse float, random float, floor to int, stuff like that. Yes?
Oh, okay. So into
So you
float,
can
I'm guessing,
basically
is a
convert
converter.
things. And I basically encourage you to find any and all chips that look like they make sense to you. Just spawn them in and be like, oh, that's what that does. Because that's how you really do the majority of the learning. Like, you kind of look at it as like, oh, I see. There we go. So yeah, floats and integers. Strings. Strings can be any character, essentially. Any character that we have in the game. So let's say you look at your keyboard in your chat. Anything you see there, you can pretty much put into a string. I'm not sure if there's limitations. I guess there are some, but from
512 character limit.
there we go. I have never tested it. Yeah, there are character limits, of course, but like, as in, you can put numbers in this if you want to. Like, if you were like, I want a number. So let's say you want to put a number on a text gadget, you can't just use a float or an int and just dump it into a text gadget. You have to convert it to a string first. Of course, if you search it up in your CV2 chips, you will find that there's also a bunch of ways to convert strings from strings or to strings or stuff like that. So yeah, to string. Basically, you can connect almost everything to a to-string. I think sometimes it gives you like really confusing answers if it's something that isn't really meant to be converted, but most of the time it'll let you just convert it. So yeah, strings in a nutshell. So these variables are not the only ones. There's other ones. You can address players. You can address direction someone is looking or someone is facing their hand or whatever. Vectors, quaternions, all that. You can address objects. And also, all of these have lists versions. That's for like dumping a at once into, one variable chip. I personally haven't seen many ways to apply that yet, because I tend to just create a list when I need it and not save it onto a variable chip. But you technically can if you need to, because reversing a list and getting something useful back out of it is a bit janky in my opinion, and unless you specifically need it, I would advise against using them unless you really have to use them, because they can be a bit weird every now and then. But yeah, basically you have these four, which are the most important variables, and you also have list versions of all of these, as well as player, rec room object is what they call it, but it's basically object data. So let's say, I don't know, let's say a trigger volume is technically an object as well. So you could address that. But it is sometimes really important to sync variable chips if you want to do a bunch of things for everyone. It's just a configurable option that you find when you configure the... Who's that? That. Right. There we go. It's just a configurable option on these chips, but what's important is that they're dependent of what you name them. So let's say you want to set up a variable chip, let's say, and you put cookies into the string, and you want every chip that is called random string, you just call the chip random string. So every chip, if you want it to be synced, it needs to have that name and needs to be synced. So probably best to just clone the chip around, and once you have fired an execution into it and saved that very variable into that chip, it will output it on all the chips that have the same name and are synced. So basically, if you want to have a bunch of endpoints for that, that's how you would do that. So now we have that out of the way. Events. Events, basically. Events are extremely important. You really, really need to utilize them. I know I didn't touch them for the longest time. I just got around it by like multiplying executions using like delay chips. Because in a delay chip, if you fire an execution into them, you can get executions out of them. That's an incredibly stupid way of doing things, but you can do it if you want to. I'm not going to stop you because I was this dumb. But this is what events are for. Let's say you have one execution and you want to put it in multiple places. Let's say you have 10 light bulbs that you want to turn off and on at the same time. That's what you would use probably an event for, would make the most sense. You have 3 different types of chips that make up the event. There's the event definition chip, which is basically you make the event, which is like you put the name for it, you spawn the chip, you input the name, what you want to call it, and you press apply or submit or whatever the button says, and then you have that event. But then you just have it. Then what do you do with it? Well, that's what you have senders and receivers for. The sender basically does exactly what it says. Once you fire an execution into it, it will send that execution to each receiving part that is configured onto that event. So let's say I make an event called, what would I call the event? Let's say game start. Let's say you're making a game. You're making like a sick paintball game for your friends. You would call it game start. So the event is called game start. You would configure the sender chip to be set onto that event. And what you can also do, you can set up this event only happens locally, or if it happens for the room authority, or for everyone. So it will be sent for everyone in the room on this side of things. So once you spawn in the receivers, you just kind of configure them to be the same event as the sender, and all of them, as many as you want to spawn, will get an execution this side. So it's kind of like remote control, basically. You can have as many receivers as you want, but you can also technically have as many senders as you want. That's not really a problem. Does that make sense?
How do they know which one's which? Like how does the event receiver know that it's coming from the event sender? Like how are they linked? Is the question. I guess.
You define the event beforehand. So let's say, as I said, you would call it game start, and then you configure both the receiver and the sender to be on that event specifically, and then they know that they
Okay.
belong to each other.
Oh, okay.
Yeah?
So there's a way of doing that when you configure it or something.
Yeah, there's
Yeah.
a third chip that's not present up there. called
Yeah,
the
the-
definition.
Cool.
The event definition chip. Actually, I'm gonna spawn
I
it.
see. Okay, that's why.
I was gonna build that chip, but then I got super sick, so I didn't do it. Don't mind me. So yeah, this is the event definition chip. That's all it is, really. It's just this tiny thing. You just put a name in it, whatever you need to call the event. As I said, I would call it game start. And you just press submit. You can configure it. You can also add various variables that are through as you fire an event. So you could set it up that once you start the event, you can also grab player data on the other side of things if you want to. So you can add. Someone's configuring it. Anyway, you can configure this as a variable, so you can add a variable to this, and each of the senders and receivers will be able to parse through other data that you want to, like numbers, players, text, whatever you feel like. Essentially, all variables, basically. You can parse through these events as well. Make
Nice.
sense? Yes?
Yeah.
No? Good?
Yeah.
Questions? No? Good. All right. I think I've bored guys enough. I'm gonna. Oh no! Oh no! Not yet! Not yet. I have for one thing. So yeah, receivers have a few more things that you can do with them. In fact, I encourage you to spawn one in right now. Go into your CV2 tab. I hope you all remember to find it. Search for the event receiver and spawn one in for yourself, so you don't take your fellow neighbor event receiver, and then you just kind of configure it, and you can look at all the events that you have. There's a bunch of events. There's room loaded, which does exactly what you think it would do. It fires an execution once the room is loaded. Room reset, which fires an execution once the room is reset. And player left, player joined, AI spawned, yada yada yada. You can have a bunch of events fired depending on what happens in the room. Most important, that's something that I said earlier, the up to 30 hertz function, which is very, very, well, it's kind of necessary for a lot of things. It fires 30 executions a second, so if you want to very much check something or fire something a lot of times, let's say you have a piston that gets a lot of different data, like a lot of different numbers, but you always to be having it moving all the time. You want to have it on a 30 hertz. That will cost a lot of network heat because it will move for everyone. Like everyone will be able to see it, or whatever it's moving, everyone will be able to see it. So if you use a 30 hertz receiver, you're firing obviously a lot of execution. So you want to be on it if you absolutely need it. But it is a useful tool. So if you need it, use it. Yes? Yes? So yeah. I'm gonna try and see
Your
if I can
event sender
find...
doesn't say button press, doesn't it need to say button press?
Yes, it does.
Oh yeah, you need to it doesn't say it for me. There we go,
Okay.
yeah.
There we go.
No, do
Yeah.
it.
Yeah. No physical connections in between.
That's cool.
Cool.
You know.
Alright. Is there anything else I
Let me
needed to
see.
say before we start doing crazy stuffs?
Button press.
No. Alright. I'm going to
What is that?
give you a
press
last
button
chance
just
to...
Okay.
I'm going to give everyone a last chance to ask things. If there's anything confused you so far, that, you felt like, oh, I don't quite understand this. Okay.
Which one was this for again?
That's
This
the
is the
definition.
event definition.
Definition? Okay.
That's for like making something appear in this list of these two, so you can actually find
So you
something
can
that
label
they
each
know.
of the other two.
But do you need to have that for it to work?
Yeah,
Okay.
yeah.
Yes.
You need to define an event beforehand.
Okay.
Okay, so like with CV1, the button could be wired directly to the emitter, but this is a different process where you have to have this event in between.
You don't have to have the event. You don't have to have. You could directly connect this. That does work. It's just that, let's say you have one button, but you have 50 confetti emitters. Not that you have the ink or the network to do it, but let's say you would have to use these because you can only connect this output to one thing. You can't connect it to multiple things. But say you just have a bunch of things happening. Yeah, you can just kind of clone this, and as long as you make another event receiver, once you press this, it will do it for all of them.
That makes sense, yeah.
It's kind of for like routing and switching, essentially.
I just don't understand this. What does this automatically come up? This button press? Like I don't understand how that works.
No, he
No,
typed that in.
Yeah, you can
Oh,
type
he just
whatever
typed
you
it
want
in.
to call it. Yeah.
But it's not.
It's-
Is it
it's-
tied to the button itself somehow? Like how
No,
does?
no, no.
Oh,
It's tied to the
it's just
receiver and the
combining those
sender.
two though. Oh, I see what you mean. Okay, so that
You have to
that
spawn
means
all
that
of them
they're
in
linked.
manually, though.
Norway named it button press so that the event sender and the event receiver could both
The
be
event
named button
receiver.
press, and they would be able to connect to each other.
Oh, okay. What's that chip called? The one that he named button press in the middle.
That's
That's
called the
event
definition,
definition.
the event
Yeah.
definition.
Event definition. Okay, cool. Thank you guys.
Just whenever you look up anything, like when you need events, just look like search event, and there'll be 3 chips in the first line. Just get all of them. That's all I can tell you.
Right.
Like that's how you not miss it.
And name them all the same
Yeah.
thing.
Yeah. Well, you name the event definition, and these you just configure because then it starts appearing in the list. That's all you
Okay.
really need to know.
So
That
if you
makes
have
sense so far?
Multiple buttons. If you have multiple buttons, you have to create a different name. You can't just have button press for every button. You have to have button press 1,
you could.
button press 2, button press.
You could.
Because it'll trigger. For example, if I had 2 buttons, and I want to name them both button press, it would do every but the things that you want to happen with one button and the things you want to happen with another button, right?
You can, if you want to have multiple buttons that the same thing, you can connect them. But if you want to differentiate, you would need different buttons, yeah.
Okay.
But you technically, if you want to have 50 buttons doing the same thing, you can all wire them to the same thing if you want to.
Yeah, if they're all
That
over
is
your
possible.
map, so they're not just in one area, you can turn
Yeah,
the lights
I was
on from
thinking-
that room or that room, or
Yeah. I was thinking kind of the opposite.
Exactly.
If you have 10 buttons that all do different things, you can't have
Oh,
just
yeah.
button press as you'd have to have try to remember this is button press 2, or this is button press something. You can't have them all button press, or else any button you push will do the same action, right? You have to kind of remember.
Exactly.
Yeah.
So you have to-
In those
it's kinda like creating a new
scenarios,
password.
in those scenarios, you probably just wouldn't use events and would just directly connect them to whatever you're trying
Yeah.
to do.
Still going further.
Okay.
Or
Or
maybe
maybe
formats.
use the OR chip, because if you have a few
Anybody got
things you
some
want
bug
it to
spray?
do, you could do
No, you don't have
the
to do
button
that.
to the
You
OR,
can
and then-
you can just connect it directly. There should be no problem.
Yeah. Like you wouldn't have to do this if you just wanted a very simple thing like turning on a light and on and off. You don't have to do this. Let's say you have one central light switch for everything, then events would make sense, because otherwise you'd have to like use these outputs on this side, because what a lot of these circuit boards have, they have an input and an output. So if you fired an execution to turn on the light, it will also put out an execution on the other side. So you can daisy chain things. But that's very confusing to a lot of people, including me. So it's probably easier to just do it with events. So you have one central light switch, and then it's wired to a bunch of event receivers. But if you just want to have like one thing does one thing, you can just wire it directly. You don't have to do the event business. You'll just have to see what's applicable for your case, as he said. Makes the most sense.
Yeah, that makes sense, yeah.
Cool.
Good. All right, everyone has their partner. That's good.
I'm dying to know what that was supposed to do.
Good- good-
I don't know what this person is.
automatic.
They're asking for an invite, and I have no idea if they're an adult or not.
It was what, sorry?
All right, fine. You do you.
Uh,
All right, sure.
Together.
Cool.
Shan
So the
Game Play.
first,
That makes
the
sense.
first task is going to be rather simple. Spawn yourself a spotlight, a CV2 spotlight, and turn it off using a button because by default it'll be on. So just spawn a spotlight, spawn a button, turn it off. You have to do the wiring. Good luck.
Tempted to go CV1 with this.
Okay, so you do it, and I'll watch. I need to take my...
I heard that.
I prefer to let you do most of it. Since
Oh wait, I can figure this
familiar.
out. Oh, this guy knows
It will
me
be
from
on by
Alan
default.
VR's
So you have to
video,
turn it
so
off using
that's the only
a
way
button.
I know this guy.
CV2.
You can also use the trigger volume if
Here you go,
if you
mate.
like that, but
No,
Okay, so you spawned in a
no,
light
no,
bulb?
no, just turn on.
Oh, wait. It's
I
in,
mean,
is it in the gadgets?
there we go.
nice. All right, you guys managed.
Did you say spotlight?
There we go.
Yeah,
Okay.
if you want to, you can also spawn a normal light, but I guess the spotlight is a bit
No.
more punctual, so it's
Is that good?
just a spotlight.
Yeah.
Thank you. Hold on.
Cool.
What do we need to
You
do?
guys
with it?
managed.
Okay, so you have a button
Apparently
and
it's
you have a
already
light.
Turn it off. It will be on by default, like you see my hand is lit up. You'll have to
Ah.
use either a trigger volume or a button to turn it off.
Accidentally hit a button.
Okay.
Opens.
I feel.
Oh no.
You can use any button you want, as long as I can look at it. You guys have turned it on.
So we can test it. I could turn
But you guys already managed.
Spotlight.
That is the correct
Hello,
setup.
mate.
To turn
So,
on, let me
Like,
see.
you do what I did. Press. Yeah,
Yeah.
we did the same thing.
Oh, it's
Remember
Saturday.
the left
Oh.
side is the input side and right side is the output
How
side.
do you know what day it is?
So if
Well,
you
I
want...
completely forgot.
Wait.
Ah,
That's
yes,
sus.
yeah.
Dun,
Hang
dun,
on.
dun,
I
dun,
usually show up
dun.
to Saturday.
Go on.
Just to make it look more clean.
You press going to turn off.
I mean, I'm like, I'll
No,
do
no,
it if I
it's
can
it's
do it,
actually
but
like this.
I
Like the
probably
left side of
won't.
the
I
chip
don't know
is the
what's
input side and the right side is the output side.
I
Is it
know.
on or off?
Okay, yeah.
here. We can get pi cent
It's
because
mine.
So, yeah, I was trying to,
Dun,
trying to take it from there to anyways. Um,
It's hard to tell.
There is
we can get pi
costume.
cent.
Yes,
You
I
guys
did.
have
I did say I might.
You guys have the right setup. That's good.
We've got your back.
You have the right things, but you still need to wire it up.
We can do with the mod,
Oh, was
right?
it the... Uh-oh.
Yeah, I don't
Okay,
know
you have
where
the
I'm
right
going.
things.
My hands are not
Pi
working.
cent. He's logged in circuit.
How to do this, Phil? Phil,
Are you
quick,
guys
tell
having
me.
problems?
Joku, are you cheating off our button?
I should...
Okay, let's see. Gotta find the button.
I'm just joking. I said, are you cheating off of our button?
Definitely on
Did
that
you
one.
came
No,
over
I
here.
think, yeah, no, I just to check that I
Okay.
did right.
Right.
Look, this
Stick in
mine.
between them.
That's what we're supposed to do.
You can just wire it directly. Just
Okay,
use the
so-
use the wire tool and wire one thing to another.
Oh,
Did you wire the button to the chipstick?
Go over so I can see.
No.
right, here we go.
So my thought is
Turn that around a bit.
and it's
Yep,
on-
boop, bitty boop. Okay, looks good.
Oh, I got
Wow, it's
one.
bright.
Stop it.
come up to true.
Worst.
But if it's off,
Around all the
There he is.
I have a hard time
Turn
doing
on.
the basic
There
one.
is the switch.
The light
You won't be
didn't
turning it
make
off
work
because
this
it's
way.
on by default.
This actually seems a lot easier.
Yeah,
And
I'm really interested to learn more of the
that's
CV2
turn on. You want to be
just
turning it
of
off
How
because
Oh,
it
on
does
it
seem
and
like it's a
it's
little
on
bit
by
more
default.
robust for doing stuff, whereas the other one was all hacky everything.
So I think you gotta.
It's very straightforward.
We're gonna try and
Oh,
build
okay.
something in circuit thing.
You mean it? Yeah, that's the right setup.
Yeah.
No,
How are you
turn
guys
it
doing
on.
over here?
If you click it, that looks good. Turn the light on. You click
That looks
again,
right.
turn it
That's a good setup. I like that. Why do you give us
Oh,
that?
what happens if we push it again? It's not going to do anything.
If on
How do we
is
get it turned
true,
off?
His audio is a
we
bit
would turn it
You know what
off.
I mean?
Oh, I did that wrong.
I think so.
So we want
So that's turning it
to-
on. You
I'm really bad
want
at
to turn it
these
off though. So you need to wire it to
That's
the other
all my.
Okay, that's what he did have it at.
things.
Don't feel.
Oh yeah, that's a pretty smart setup. Yep, that's good. Yeah, that works. That's good. Yep. So it seems like mostly everyone has figured it out. Oh, you guys are
Oh,
advanced.
do you even need the pulse?
There.
All right. So that seemed a bit too easy for you guys. I'm gonna make it a bit harder.
Did everybody get it?
But it didn't
So-
seem like it was.
Does yours
For
work?
the next task, I want you to turn the spotlight back on again, but this time you have to use an event. So make the event something you want to name it, preferably
use an
something
event.
completely weird and random that no one else is using, so you don't accidentally use the same event.
Yeah.
And yeah,
We need it so that
go.
you know, like in instance.
Well,
like,
I'm off to think
like
tank.
when we, like when we
Okay.
press-
Have fun thinking.
So,
Phil.
so bad.
Wait, so for
Okay.
every event
Okay.
says button
Phil,
press and you
I'm
have
waiting
an event
there.
with
Over here.
button press,
Ah, yeah, there you
are
go.
they both going to do the same thing?
So
You
I
know
was
the,
trying to do a
events?
toggle where you hit the
Event
button
chips
and
are?
it checks if it's on or off, right? And then
Gotcha.
So with an event.
if on is true, then turn it off. If on is false, which I don't have wired,
So
then
it's
turn it
always
on.
they have the same name.
Not quite, because you don't have an output from the from this. Like you would have to have it from this. So sadly, there's no real way of knowing if the light is on. I think there's a chip that lets you do it.
And then we can.
Okay.
Yeah, we
If you
could-
look up light,
So it says chip settings.
No worries. Yeah.
So I
there
could
we go,
get
let me
rid
see.
of.
Okay, so there's no chip that if the light is on or off. You'll just kind of have
Oh,
to
change the name.
make
Okay.
sure that when
So what
you
am I
turn
gonna
it
change
on,
it to?
just set the execution
Oh,
to
sorry.
turn off.
Which one are you doing? The
So
event definition
you
or the
probably
event?
want to be doing something
The
else
event
instead,
definition.
like making a
So
static
you're gonna leave
variable,
that as
flip-flops instead, because there's no way
Okay.
of doing
Let me see
it
it.
in the old way of CV1.
yeah. Go
But
ahead.
yeah, basically
Okay.
just wire an
Wait.
event so you can
Here,
turn it
configuring
on
I just
using an
checked
event.
something.
That's all.
Wait, what?
You're still configuring it, right?
So I clicked on that, and I wanted to change. What do you want me to change the name to, or you don't want me to do that?
Just any.
Hey Phil.
Hmm?
Hey,
okay,
Bisons?
so
Oh,
I'm gonna,
okay.
Cat
I'm gonna go to what is the circuit think tank with swag.
All right.
Okay, I changed it to ammo.
See you later.
This AMO.
See ya.
Now
All
we
right.
go to the event.
Hey, who broke that? Damn it! That was for later.
We
can do
How are you getting home now?
You move your gun, your
I
maker
should have
pen.
locked that. I'm gonna
click
reset
on
it
that.
since no one noticed.
Let's see, figure.
Figure out, and I have no idea what I'm doing here.
I don't either.
Like,
can we rename it?
multiple?
Let's see.
Don't film us, okay? We're rubbish at this.
Oh, wow.
We're not a good example.
How do I know if the thing's even on?
Wait.
Yeah.
Like, I can't even see
Do,
it.
should I turn this to nighttime,
Okay.
everyone? Would that make actually that would probably make things
And
really
then,
hard to
does
see.
the
then.
event receiver have to go light bulb?
Yeah.
Wait, did I do
Or
it?
no, I mean it has to go to that thing. Yeah.
Do
Okay.
we switch it? Dark?
It's kind of like a
Yeah,
wireless
let's try that, because I can't see anything.
between the two.
Right.
Us
But
questions
this has
are
to be wired
supposed
to
to-
that, right?
Yeah, the event receiver
Yep.
has to be wired.
I have an idea.
How do you do that?
What if?
You
Wait,
just wire this little red part
It's not gonna work.
to the turn off or turn on.
So the wire button?
Yeah.
I don't understand what I don't understand what local
Okay,
means.
and so where
Like
does
when
it
you
go
was
to?
talking about local and non-local.
Local is on your
Turn
headset.
off or turn
Yeah,
on.
exactly. No,
It's
nobody
just
else
you
can
and
see.
your
it.
headset.
Yeah.
So,
Oh, okay. And then if it's not local, that means everyone can see it. I see. Okay. I wasn't
Yeah.
sure what he meant.
Is it right?
Receiver.
Bring it back.
Kiva.
This is, I think,
Yeah.
everyone's
So it does turn it off, but it doesn't turn it back on. Because the event is only turning it off.
Yeah.
Event receiver. So when this event is going to receive it, we're going to want to turn the light off.
Where's my Kiv off?
Okay.
I don't see it anywhere. That's weird. I just created
So-
I mean,
the...
we got it to do what
When
it's
this
supposed to do,
event,
but...
when we fire this event sender, this gets fired.
Okay, so
This
if
executes right here.
it's off,
So we want to make the execute turning off
then
the
we
light.
want it on. And if it's on, we want it to go off. Can we do that with the if button?
Sorry, I have no idea what that means.
So, the third task is going to be a bit more tricky. You'll have to apply a change of the variables on the spotlight. So, what you can change on the spotlights is color, intensity, range, yada yada, depending on whatever you have. But I think everyone has the spotlight, as they should. So, what I want you to do is to go ahead and change the variables on your spotlight. So whatever you want. You don't have to change everything. I want you to change at least one thing. So you can change color, you can change intensity, whatever you want. But I just have to see that you changed something. But you cannot use the configure tool. You have to use it, like you have to use whatever you want to. Like a button, trigger volume, you know, you can put the value directly, you can use a variable if you want to. Use whatever you feel like. Then we're going to use a NOT gate.
The light color should change. Let me try making it a different.
So you just kind of invert this. It's wired to that. This is kind of a cross. So basically, this is connected to that. And every time you get an execution, there we go. There it is. It will fire. It will fire them back and forth.
It goes to the
So just
variable.
connect it to
Maybe
that
like that.
and that, and that technically,
Set color, and then the color.
if I didn't break
Yes,
it,
it did change.
Sweet. Okay,
is
yeah.
it low
so
range or what's going on?
The set color.
No,
is
these-
setting
you
can't
itself
use-
to change the color and then the number.
It's turning on.
Oh,
color to go to.
I'm stupid. I forgot something. I forgot
The
to
green.
hold on.
Okay, so you had to go to the set color. So the button
Yeah.
pushing
What
it
are the different
set
colors
Well, actually,
there?
we don't
and
need
then
that.
the green
Like there is
tells
the
you what
orange
color
line,
set
there is a
it
pink
Hmm?
line.
Yeah.
These are the variable, like the various like variable kind of
Well,
things.
can you
So
put
the
a Boolean chip
orange
so we
is
can
the
turn it back on?
executions, and the red
That's
ones
really
are the
annoying me.
booleans, and the
okay.
green ones integers. These just basically these
They're
variables
talking
over
about it
there,
up
and that's basically what it is. So I did an
I
oopsie here.
see.
There we
So
go. This
pink-
passes
so the
through.
pink ones. Okay, so pink means like
There we go.
variable transition.
Okay,
So
so,
if you
I understand it's send receiver, so I understand that. So
Mhm.
it's coming into here, and it's, what is
If you
this?
search chips,
This
they
is
do
your
have
This is
Boolean?
just this is the Boolean variable chip. Like it saves the current state of the Boolean,
Yeah, you're right. I don't see it either.
and
Okay.
this just inverts it and puts it back in.
Very
Okay.
cool.
So it's just changing
So-
it. Okay.
Yeah,
Okay.
it only applies it though when it gets execution. That's when it applies it. So you kind of made like simple storage for this, and then we'll flip on and off.
Okay, so this is just storing a 1 or 0. Kind of. On or
No,
off.
it just stores it. It just stores. Yeah, it's 1 or 0. If you hover over with your pen, like with your wire tool, be careful not to unwire anything. But like hover over
Uh-huh.
this one, and you will see it says false. And when I press it, it says true.
Make it like
But up here it inverts it again. So it inputs false, but it doesn't apply it yet because it didn't get another execution.
Wait, so
But
then
if it does, it will turn it off again.
Oh,
I
You
haven't
know?
wired any of these spots.
I'm
So
not
we'll
seeing
keep
true or
inverting it
false. I'm
every
just
time.
seeing. I'm just seeing
no, you don't
false.
need that.
You need to press the
I'd
button.
always
It's happening.
That one. Will that one work?
Yeah, you
Oh,
want to press
because it's local.
if it's-
Because it's local, of course. Yeah, sorry.
Yeah, if you
I
sync
keep
it though,
forgetting about
if you
the whole
configure
local
it,
thing.
if you configure it and you press
You
sync,
said it's like
you will see
said
it,
that
like,
one
and
like
we'll
a
see it.
storage chip.
and you will also see that the
So if
network
it's
heat is
false,
going up
it'll
every time you press it.
Why-
Wait, what's the sync thing? I don't understand what that is. Sync mean that everyone sees it now?
Not only
Do you
that,
remember
but
how
you can
local is
have
just on your headset? Local's just
yeah,
on your
yeah,
headset.
yeah.
Sends it to
What is
everybody's
sync?
headset. It sends it to
So sync
everybody.
just means that sends it to everyone. Okay.
yeah. So look up here. This isn't connected to literally anything.
Get
Nothing.
a-
Completely nothing. It has the same name as this,
Yeah,
and
how
it
do
is
we make
synced.
it go back
Oh.
So
on?
if I press this now,
Mhm.
you will see that this
Because
is
we had
for
the
whatever
color,
reason,
and it definitely changed the color.
Wait, is
to
it saying
blue.
true?
Oh,
It
it says
should be.
true. It says true.
Yeah.
It says true.
even though it has
Yeah,
nothing connected to it.
So
Why?
you're correct
Is it
on
because
the
you
variable.
just
It's
called it
the same
exactly
name?
what you want.
Yeah,
Ah,
and it's
'cause it's synced.
You
synchronized.
want
So-
the
It's synced.
pool, right?
Yep.
That's what this is
Oh,
for.
okay.
Um,
So it's not actually.
So,
wait, if you synced it,
what
does
you
that
wanna
mean
do
that
is
automatically
to-
is
you also
non-local?
have
Like
this
it's
nut here,
for
that's
everyone?
good.
Yes.
You want to, when you press the
By
button,
cross network heat.
whatever button is going, or whatever
So
is going
if
to
you look at it,
7.
once you press it,
It's going to
the
tell your-
network
your
heat will
light.
go up a tiny bit.
just have this.
Like look into your
this variable
circuits v2 tab,
be set
and you look
to
at
the
your like
not
Yeah.
CPU
itself.
and network, and once you press it, the network heat will go up a tiny bit.
Execution of the variable.
When you
mine's
click
not
the
going
See
up. Or maybe I have to press it.
This,
Do I have to
so
press
Yeah,
it?
press
Right
the
now?
Yeah, you have to
button,
press
This
it.
is the value.
Oh,
of the
yeah,
variable,
yeah,
and right
yeah.
now
I
it
thought
is false.
network meant that
You
everyone's
want
network
it to
would
be,
go up
you want
straight
you want
away
to set this
automatically when
variable
someone
to
presses
the
it.
opposite of
Not
what
that I
currently
didn't know
no,
that
no.
was
Seven.
only
you
for
want
me.
it to like
Okay.
go back and forth.
I should have probably said
So
that. Like it only
you
goes
want
up
to
for
take
you.
this
the person.
output and plug it into a
Okay.
NOT so that
Because
it becomes
CPU
true
is
if
obviously
it's
different.
false,
CPU,
or
it'll
true or
get
false if
triggered
it's
for
true.
everyone.
That's
Um,
entirely CPU is entirely
like
local.
that.
And then do we need another event receiver to go
What was
to
this
that
chip
variable?
called? This was a Boolean chip?
If you don't
Boolean
plan on
variable chip, yeah.
using one of your already existing ones, yes.
Well, right now when we push the button,
Will flip-flop between true and false. So then,
but we
you
still need to
take this
connect it up
if.
to there.
Yeah, so that's the next step. You're going to want to
Okay.
take this if to check if this is false or true.
Wins.
So that condition will be the Boolean variable output.
Okay.
And then, so if the
So if it's
bool,
false, then turn it on, and that way if it's true, it'll turn off.
yeah, so you want, if it's true, it'll turn on, and if it's false, it'll turn off.
False,
So
it'll turn off.
this then is going to output if your condition is true, and this else is going to execute if your condition is false. So you want your condition to be the output of this variable, so that you have like, if you press the button, it's false, and if it's false, it sets the light to be off. If it's
Okay.
true, it'll set the light to be on.
Wait, you still need to wire it.
Yeah, no, I'm just seeing that like when we push the
Oh,
button,
okay.
variable turns from true to false.
So one more quick thing about the variable. As Phil has mentioned a few times, did I move that? Oh, never
I
mind.
moved that, my bad.
So if it's run locally, so for every player's machine, they might see different results. And that is true of these variables. If you configure the variable, there's an option for synced, and that'll make sure that everyone sees the same value inside of that variable. And so that's probably
Okay.
what we want here.